Chapter 11 of Some Problems of Philosophy, a Beginning of an Introduction to Philosophy, by William James. Recording is in the public domain. Novelty and the Infinite, the Perceptual View. Kant's and Renouvilier's dealings with the infinite are fine examples of the way in which philosophers have always been wont to infer matters of fact from conceptual considerations. Real novelty would be a matter of fact, and so would be the idealistic constitution of experience. But Kant and Renouvier deduced these facts from the purely logical impossibility of an infinite number of conditions getting completed. It seems a very short cut to truth. But if the logic holds firm, it may be a fair cut, and the possibility obliges us to scrutinize the situation with increasing care. Footnote. Let me now say that we shall ourselves conclude that change completed by steps infinite in number is inadmissible. This is hardly inferring fact from conceptual considerations. It is only concluding that a certain conceptual hypothesis regarding the fact of change will not work satisfactorily. The field is thus open for any other hypothesis, and the one which we shall adopt is simply that which the fact of perceptual experience suggests. Proceeding so to do, we immediately find that in the class of infinitely conditioned things we must distinguish two subclasses as follows: 1. Things conceived as standing, like space, past time, existing beings. 2. Things conceived as growing, like motion, change, activity. In the standing class there seems to be no valid objection to admitting both real existence and a numerical copiousness demanding infinity for its description. If, for instance, we consider the stars, and assume the number of them to be infinite, we need only suppose that to each several term of the endless series 1, 2, 3, 4, n, there corresponds one star. The numbers, growing endlessly, would then never exceed the stars standing there to receive them. Each number would find its own star waiting from eternity to be numbered, and this in infinitum, some star that ever was, matching each number that shall be used. As there is no all to the numbers, so there need be none to the stars. One cannot well see how the existence of each star should oblige the whole class star to be of one number rather than of another, or require it to be of any terminated number. What I say here of stars applies to the component parts of space and matter, and to those of past time. Footnote. Past time may offer difficulty to the student, as it has to better men. It has terminated in the present moment, paid itself out and made an amount. But this amount can be counted in both directions, and in both one may think it ought to give the same result. If when counted forward it came to an end in the present, then when counted backward it must, we are told, come to a like end in the past. It must have had a beginning, therefore, and its amount must be finite. The sophism here is gross, and amounts to saying that what has one bound must have two. The end of the forward counting is the beginning of the backward counting, and is the only beginning logically implied. The ending of a series in no way prejudices the question whether it were beginningless or not, and this applies as well to tracts of time as to the abstract regression which negative numbers form. So long as we keep taking such facts piecemeal and talk of them distributively, as any or each, the existence of them in infinite form offers no logical difficulty. But there is a psychological tendency to slip from the distributive to the collective way of talking, and this produces a sort of mental flicker and dazzle out of which the dialectic difficulties emerge. If each condition be there, we say, then all are there, for there cannot be eaches that do not make an all. Rightly taken, the phrase all are there means only that not one is absent, but in the mouths of most people it surreptitiously foists in the wholly irrelevant notion of a bounded total. There are other similar confusions. How, it may be asked in Locke's words, can a growing measure fail to overtake a standing bulk? And standing existence must some time be overtaken by a growing number series, must be finished or finite in its numerical determination. But this again foists in the notion of a bound. What is given as standing in the case under review is not a bulk, but each star, atom, past date, or what not. And to call these eaches a bulk is to beg the very point at issue. But probably the real reason why we object to a standing infinity is the reason that made Hegel speak of it as the false infinite. It is that the vertiginous chase after ever more space, ever more past time, ever more subdivision, seems endlessly stupid. What need is there, what use is there for so much? Not that any amount of anything is absolutely too big to be, but that some amounts are too big for our imagination to wish to caress them. So we fall back with a feeling of relief on some form or other of the finitist hypothesis. Footnote. The reader will note how emphatically, in all this discussion, I am insisting on the distributive or piecemeal point of view. The distributive is identical with the pluralistic, as the collective is with the monistic conception. We shall, I think, perceive more and more clearly as this book proceeds, that piecemeal existence is independent of complete collectibility, and that some facts at any rate exist only distributively, or in form of a set of eaches which, even if in infinite number, need not in any intelligible sense either experience themselves or get experienced by anything else, as members of an all. End footnote. If we now turn from static to growing forms of being, we find ourselves confronted by much more serious difficulties. Zeno's and Kant's dialectic holds good wherever, before an end can be reached, a succession of terms, endless by definition, must needs have been successively counted out. This is the case with every process of change, however small, with every event which we conceive as unrolling itself continuously. What is continuous must be divisible ad infinitum, and from division to division here you cannot proceed by addition, or by what Kant calls the successive synthesis of units, and touch a farther limit. You can indeed define what the limit ought to be, but you cannot reach it by this process. That Achilles should occupy in succession all the points in a single continuous inch of space is as inadmissible a conception as that he should count the series of whole numbers 1, 2, 3, 4, etc. to infinity and reach an end. The terms are not innumerable in that order, and the order it is that makes the whole difficulty. An infinite regression, like the rearward perspective of time, offers no such contradiction, for it comes not in that order. Its end is what we start with, and each successive note more which our imagination has to add ad infinitum is thought of as already having been paid in and not as having yet to be paid before the end can be attained. Starting with our end, we have to wait for nothing. The infinity here is of the standing variety. It is, in the word of Kant's pun, gegeben, not aufgegeben. In the other case, of a continuous process to be traversed, it is on the contrary aufgegeben. It is a task, not only for our philosophic imagination, but for any real agent who might try physically to compass the entire performance. Such an agent is bound by logic to find always a remainder, something ever yet to be paid, like the balance due on a debt, with even the interest of which we do not catch up. Infinitum in actu, per transire nequiet, said scholasticism, and every continuous quantum to be gradually traversed is conceived as such an infinite. The quickest way to avoid the contradiction would seem to be to give up that conception, and to treat real processes of change no longer as being continuous, but as taking place by finite, not infinitesimal steps, like the successive drops by which a cask of water is filled, when whole drops fall into it as once or nothing. This is the radically pluralist, empiricist, or perceptualist position, which I characterized in speaking of Renouvier. We shall have to end by adopting it in principle ourselves, qualifying it so as to fit it closely to perceptual experience. Meanwhile, we are challenged by a certain school of critics who think that what in mathematics is called the new infinite has quashed the old antinomies, and who treat anyone whom the notion of a completed infinite in any form still bothers as a very naif person. Naif though I am in mathematics, I must, notwithstanding the dryness of the subject, add a word in rebuttal of these criticisms, some of which, as repeated by novices, tend decidedly towards mystification. The new infinite and the number continuum are outgrowths of a general attempt to accomplish what has been called the arithmetization of all quantity. Certain quanta, grades of intensity or other difference, amounts of space, have until recently been supposed to be immediate data of perceptive sensibility or intuition. But philosophical mathematicians have now succeeded in getting a conceptual equivalent for them in the shape of collections of numbers created by interpolation between one another indefinitely. We can have any line in space, and have its halves and so on, but between the cuts thus made and numbered, room is left for infinite others, created by using 3 as a divisor, for infinite others still by using 5, 7, etc., until all possible rational divisions of the line shall have been made. Between these it is now shown that interpolation of cuts numbered irrationally is still possible ad infinitum, and that with these the line at last gets filled full, its continuity now being wholly translated into these numbered cuts, and their number being infinite. Of the celebrated formula that continuity means unity in multiplicity, the multiplicity alone subsists, the unity disappears, as indeed it does in all conceptual translations, and the original intuition of the line's extent gets treated from the mathematical point of view as a mass of uncriticized prejudice by Russell, or sneered at by Cantor as a kind of religious dogma. So much for the number continuum. As for the new infinite, that means only a new definition of infinity. If we compare the infinitely growing number series 1, 2, 3, 4, n in its entirety with any component parts of it, like even numbers, prime numbers, or square numbers, we are confronted with a paradox. No one of the parts thus named of the number series is equal to the whole collectively taken. Yet any one of them is similar to the whole, in the sense that you can set up a one-to-one relation between each of its elements, and each element of the whole, so that part and whole prove to be of what logicians call the same class, numerically. Thus, in spite of the fact that even numbers, prime numbers, and square numbers are much fewer and rarer than numbers in general, and only form a part of numbers überhaupt, they appear to be equally copious for purposes of counting. The terms of each such partial series can be numbered by using the natural integers in succession. There is, for instance, a first prime, a second prime, etc. ad infinitum. And queerer sounding still, since every integer, odd or even, can be doubled, it would seem that the even numbers thus produced cannot in the nature of things be less multitudinous than that series of both odd and even numbers of which the whole natural series consists. These paradoxical consequences result, as one sees immediately, from the fact that the infinity of the number series is of the growing variety. They were long treated as a reductio ad absurdum of the notion that such a variable series spells infinity in act, and can ever be translated into standing or collective form. Footnote: the fact that, taken distributively, or paired each to each, the terms in one endlessly growing series should be made a match for those in another, or similar to them, is quite compatible with the two series being collectively of vastly unequal amounts. You need only make the steps of difference, or distances, between the terms much longer in one series than in the other, to get numerically similar multitudes with greatly unequal magnitudes of content. Moreover, the moment either series should stop growing, the similarity would cease to exist. End footnote. But contemporary mathematicians have taken the bull by the horns. Instead of treating such paradoxical properties of indefinitely growing series as reductiones ad absurdum, they have turned them into the proper definition of the infinite classes of things. Any class is now called infinite if its parts are numerically similar to itself. If its parts are numerically dissimilar, it is finite. This definition now separates the conception of the class of finite from that of infinite objects. Next, certain concepts called transfinite numbers are now created by definition. They are decreed to belong to the infinite class, and yet not to be formed by adding one to one ad infinitum, but rather to be postulated outright as coming after each and all of the numbers formed by such addition. Footnote: the class of all numbers that come before the first transfinite is a definitely limited conception, provided we take the numbers as eaches or any's, for then any one and every one of them will have by definition to come before the transfinite number comes, even though they form no whole and there be no last one of them, and though the transfinite have no immediate predecessor. The transfinite is, in other words, not an ordinal conception, at least it does not continue the order of entire numbers. End footnote. Cantor gives the name of omega to the lowest of these possible transfinite numbers. It would, for instance, be the number of the point at which Achilles overtakes the tortoise, if he does overtake him, by exhausting all the intervening points successively. Or it would be the number of the stars, in case their counting could not terminate. Or again, it would be the number of miles away at which parallel lines meet, if they do meet. It is, in short, a limit to the whole class of numbers that grow one by one, and like other limits it proves a useful conceptual bridge for passing us from one range of facts to another. The first sort of fact we pass to with its help is the number of the number continuum or point continuum described above, as generated by infinitely repeated subdivision. The making of the subdivisions is an infinitely growing process, but the number of subdivisions that can be made has for its limit the transfinite number omega just imagined and defined. Thus is a growing assimilated to a standing multitude. Thus is a number that is variable practically equated, by the process of passing to the limit, with one that is fixed. Thus do we circumvent the law of indefinite addition or division, which previously was the only way in which infinity was constructible, and reach a constant infinite at a bound. This infinite number may now be substituted for any continuous finite quantum, however small the latter may perceptually appear to be. When I spoke of my mystification just now, I had partly in mind the contemptuous way in which some enthusiasts for the new infinite treat those who still cling to the superstition that the whole is greater than the part, because any point whatever in an imaginary inch is now conceivable as being matched by some point in the quarter inch or half inch. Thus numerical similarity of the different quanta, taken pointwise, is treated as if it signified that half inches, quarter inches, and inches are mathematically identical things anyhow, and that their differences are facts which we may scientifically neglect. I may misunderstand the newest expounders of Zeno's famous sophism, but what they say seems to me virtually to be equivalent to this. Mr. Bertrand Russell, whom I do not accuse of mystification, for heaven knows he tries to make things clear, treats the Achilles puzzle as if the difficulty lay only in seeing how the paths traversed by the two runners, measured after the race is run, and assumed then to consist of nothing but points of position, coincident with points upon a common scale of time, should have the same time measure, if they be not themselves of the same length. But the two paths are of different lengths, for owing to the tortoise's head start, the tortoise's path is only a part of the path of Achilles. How then, if time points are to be the medium of measurement, can the longer path not take the longer time? The remedy for Mr. Russell, if I rightly understand him, lies in noting that the sets of points in question are conceived as being infinitely numerous in both paths, and that where infinite multitudes are in question, to say that the whole is greater than the part is false, for each and every point traversed by the tortoise there is one point traversed by Achilles at the corresponding point of time, and the exact correspondence, point by point, of either one of the three sets of points with both the others, makes of them similar and equally copious sets from the numerical point of view. There is thus no recurrent remainder of the tortoise's head start with which Achilles cannot catch up, which he can reduce indefinitely, but cannot annul. The books balance to the end. The last point in Achilles' path, the last point in the tortoise's, and the last time instant in the race are terms which mathematically coincide. With this, which seems to be Mr. Russell's way of analyzing the situation, the puzzle is supposed to disappear. Footnote: Mr. Russell's own statement of the puzzle as well as of the remedy are too technical to be followed verbatim in a book like this. As he finds it necessary to paraphrase the puzzle, so I find it convenient to paraphrase him, sincerely hoping that no injustice has been done. End footnote. It seems to me, however, that Mr. Russell's statements dodge the real difficulty, which concerns the growing variety of infinity exclusively, and not the standing variety, which is all that he envisions when he assumes the race already to have been run, and thinks that the only problem that remains is that of numerically equating the paths. The real difficulty may almost be called physical, for it attends the process of formation of the paths. Moreover, two paths are not needed. That of either runner alone, or even the lapse of empty time, involves the difficulty, which is that of touching a goal when an interval needing to be traversed first keeps permanently reproducing itself and getting in our way. Of course, the same quantum can be produced in various manners. This page which I am now painfully writing, letter after letter, will be printed at a single stroke. God, as the orthodox believe, created the space continuum, with its infinite parts already standing in it, by an instantaneous fiat. Past time now stands in infinite perspective, and may conceivably have been created so, as Kant imagined, for our retrospection only, and all at once. Omega was created by a single decree, a single act of definition in Professor Cantor's mind. But whoso actually traverses a continuum can do so by no process continuous in the mathematical sense. Be it short or long, each point must be occupied in its due order of succession. And if the points are necessarily infinite, their end cannot be reached, for the remainder, in this kind of process, is just what one cannot neglect. Enumeration is, in short, the sole possible method of occupation of the series of positions implied in the famous race. And when Mr. Russell solves the puzzle by saying as he does, that the definition of whole and part without enumeration is the key to the whole mystery, he seems to me deliberately to throw away his case. Footnote: The Philosophy of Mathematics, 1, 361. Mr. Russell gives a Tristram Shandy paradox as a counterpart to the Achilles. Since it took T.S., according to Sterne, 2 years to write the history of the first 2 days of his life, common sense would conclude that at that rate the life never could be written. But Mr. Russell proves the contrary, for as days and years have no last term, and the nth day is written in the nth year, any assigned day will be written about, and no part of the life remain unwritten. But Mr. Russell's proof cannot be applied to the real world without the physical hypothesis which he expresses by saying, if Tristram Shandy lives forever, and does not weary of his task, in all real cases of continuous change a similarly absurd hypothesis must be made. The agent of the change must live forever, in the sense of outliving an endless set of points of time, and not wearying of his impossible task. End footnote. Footnote: Being almost blind mathematically and logically, I feel considerable shyness in differing from such superior minds. Yet what can one do but follow one's own dim light? The literature of the new infinite is so technical that it is impossible to cite details of it in a non-mathematical work like this. End footnote. After this disagreeable polemic, I conclude that the new infinite need no longer block the way to the empiricist opinion, which we reach provisionally on page 172. Irrelevant though they be to facts the conditions of which are of the standing sort, the criticisms of Leibniz, Kant, Cauchy, Renouvier, Evelyn, and others apply legitimately to all cases of supposedly continuous growth or change. The conditions here have to be fulfilled seriatim, and if the series which they form were endless, its limit, if successive synthesis were the only way of reaching it, could simply not be reached. Either we must stomach logical contradiction, therefore, in these cases, or we must admit that the limit is reached in these successive cases by finite and perceptible units of approach. Drops, buds, steps, or whatever we please to term them, of change, coming wholly when they do come, or coming not at all. Such seems to be the nature of concrete experience, which changes always by sensible amounts, or stays unchanged. The infinite character we find in it is woven into it by our later conception indefinitely repeating the act of subdividing any given amount supposed. The facts do not resist the subsequent conceptual treatment, but we need not believe that the treatment necessarily reproduces the operation by which they were originally brought into existence. The antinomy of mathematically continuous growth is thus but one more of those many ways in which our conceptual transformation of perceptual experience makes it less comprehensible than ever. That being should immediately, and by finite quantities, add itself to being, may indeed be something which an onlooking intellect fails to understand. But that being should be identified with the consummation of an endless chain of units, such as points, no one of which contains any amount whatever of the being, such as space, expected to result, this is something which our intellect not only fails to understand, but which it finds absurd. The substitution of arithmetization for intuition thus seems, if taken as a description of reality, to be only a partial success. Better accept, as Renouvier says, the opaquely given data of perception, than concepts inwardly absurd. Footnote: The point continuum illustrates beautifully my complaint that the intellectualist method turns the flowing into the static and discrete. The buds or steps of process, which perception accepts as primal gifts of being, correspond logically to the infinitesimals, minutest quanta of motion, change, or what not, of which the latest mathematics is supposed to have got rid. Mr. Russell accordingly finds himself obliged, just like Zeno, to treat motion as an unreality. Weierstrass, he says, by strictly banishing all infinitesimals, has at last shown that we live in an unchanging world, and that the arrow, at every moment of its flight, is truly at rest. We must entirely reject the notion of a state of motion, he says elsewhere. Motion consists merely in the occupation of different places at different times. There is no transition from place to place, no consecutive moment or consecutive position, no such thing as velocity except in the sense of a real number which is the limit of a certain set of quotients. The mathematical continuum, so called, becomes thus an absolute discontinuum in any physical or experiential sense. Extremes meet, and although Russell and Zeno agree in denying perceptual motion, for the one a pure unity, for the other a pure multiplicity takes its place. It is probable that Russell's denial of change, etc., is meant to apply only to the mathematical world. It would be unfair to charge him with writing metaphysics in these passages, although he gives no warning that this may not be the case. End footnote. So much for the problem of the infinite and for the interpretation of continuous change by the new definition of infinity. We find that the picture of a reality changing by steps finite in number and discrete remains quite as acceptable to our understanding and as congenial to our imagination as before. So after these dry and barren chapters we take up our main topic of inquiry just where we had laid it down. Does reality grow by abrupt increments of novelty or not? The contrast between discontinuity and continuity now confronts us in another form. The mathematical definition of continuous quantity, as that between any two elements or terms of which there is another term, is directly opposed to the more empirical or perceptual notion that anything is continuous when its parts appear as immediate next neighbors, with absolutely nothing between. Our business lies hereafter with the perceptual account. But before we settle definitively to its discussion, another classic problem of philosophy had better be got out of the way. This is the problem of causation. End of chapter 11.